Good morning, my dear student. Hope you all are doing great. So today I am going to teach you about vapor pressure of liquid solution. So what is liquid solution? Liquid solution is that where solvent is the liquid. Okay. Solvent which is present in greater amount. So if the solvent is liquid, then it's known as liquid solution. And solute may be anything like a gas, a liquid, or a solute. Okay. So here we are going to learn about that vapor pressure of liquid solution. Okay. So first of all, what the important thing here is that here they told that liquid solvent is volatile. Such solution may contain one or more volatile components generally. So what it's mean actually? They told that in some cases there are one volatile components, or in some cases there are many number of volatile components. So what's actually volatile means? Volatile means that which can be fly away easily. Like if we are going to take the solvent which is liquid, we know that it should be fly away easily, so it's more volatile. And if we are going to take a solid, so what happened, that solid never be fly away, so solid is not a volatile compound. So in this sentence, we should learn from the sentence that one or more volatile components present in some cases. If the solution is liquid in solid, solid in liquid, then what happened? There only liquid can be volatile, but the solid is not. So in this solution, it have only one volatile component, and which is liquid. But if we are going to take another example, like if we are going to add liquid in liquid, then what happen, both the liquid are volatile. So in this solution it have two volatile components, remember that. Okay. And here we are going to learn about liquid in liquid and solid in liquid. Okay, so first of all we are going to learn about liquid in liquid solution. So liquid in liquid, that means if you have a liquid and you are going to add another liquid, then this solution is known as liquid liquid solution. Okay, so it have two different liquid, so we should name as liquid number 1, liquid number 2. Okay, so here they told that the total pressure of this liquid is P total. Okay, and for one, the pressure is, for one number liquid the pressure is P1, and for two number liquid the pressure is P2. Okay, and for one number liquid the mole fraction is x1, and for two number liquid the mole fraction is x2. Remember that. Okay, so here they told that let us consider a binary solution. Binary solution means there are two liquid are there, binary solution of two volatile liquid, and both liquid are volatile. Remember that. Okay, here we learn about a law, and which is known as Raoult law. So in case of Raoult law, you have to consider liquid which are volatile in nature. Must remember that. In the previous video we learned about Henry law, where we have seen that in a liquid, if we are going to add gas, so what happen, if we are going to give the pressure, then pressure is directly proportional to the mole fraction of that solution. Okay, so but in case of Raoult's law, must remember that don't forget to add that volatile word, because in case of Raoult law you need two volatile liquid and the binary solution of that these two volatile liquid. Okay, so in that binary solution there's two liquids, so the total vapor pressure means, see, if we are going to add, two liquid, like if we are going to it's a liquid and we are going to add a different liquid. Okay, so it have two different liquid. So if we are going to cover it cover the beaker, then what happen, after some time we see that since these two are volatile liquids, so these will be fly away. Okay, after some time it may be condensed and the droplet are in that, and they are again come back to the liquid state. So we must remember that about equilibrium, which we learned that if the rate of changing of liquid to gas and again, liquid to vapor and again vapor to liquid, then this state is known as equilibrium state. Okay, so the pressure exerted by that vapor, these are vapors, right? These are vapors, so pressure exerted by this vapor is known as vapor pressure. Okay, and these vapors from formed from these liquids only. Okay, so here they told that the vapor pressure, the total vapor pressure is P total, and for liquid 1 the pressure is P1, for liquid 2 the pressure is P2, and similarly the mole fraction are X1 and X2. So now we are going to learn about the Raoult's law, which is really very important. So here the definition of that Raoult law is, for a solution of volatile liquid. See, I told you now that in case of Raoult law you must have to include that term volatile. Okay, don't forget to include it, otherwise your definition will be wrong. Okay, so must include volatile words, because if the liquids are volatile then only Raoult's law going to applicable for that binary solution. Okay, so for a volatile liquid, the partial pressure, vapor pressure of each component of a solution is directly proportional to its mole fraction present in solution. So what they told that in case of volatile liquid binary mixer, that means they are volatile. So this is 1, this is 2. These two are different liquid. Okay, so partial, so after some time, since they are volatile in nature, so they are going to become vapor. This is vapor of 1 number liquid and this is vapor of 2 number liquid. Okay, so the vapor pressure of component 1, that means P1, component 1 of the solution is proportional to its mole fraction. So the vapor pressure of component 1 is proportional to its mole fraction, and the component 1 mole fraction is x1, remember that. Okay, and similarly component 2 pressure is P2 and the component 2 mole fraction is x2. Okay, so now I think you understand it completely. Now here told that P1 is directly proportional to X1. So if we are going to change the proportionality sign into equal, then what happened, there is a new constant are found and it's known as P1 naught, and this naught determine the pure liquid vapor. Okay, what it actually means, like, since if you are going to take the liquid 1 in a separate component, in a separate beaker, or if you are going to take the liquid 2 in a separate beaker and just cover them, then after some time what you have seen, that the vapor pressure of liquid 1 and the vapor pressure of liquid 2. Okay, so after some time, since they are volatile in nature, so they will be fly and we get the vapor here. So the the vapor pressure of liquid 1 is the purest of only for liquid 1. So that purest vapor pressure of liquid 1 only. Here we are not going to mix 1 and 2. Here only the pure 1 liquid is there. Okay, so here only the pure 1 liquid is there. So the pressure of this pure 1 number liquid is P1 naught. Similarly, the pressure of the pure 2 number liquid is P2 naught. Remember that. This naught determine the purest form of that. Okay, so from that we came to know about that P1 is equal to P1 naught x1 and similarly P2 is equal to P2 naught x2. So now we are going to learn about a new law and is known as Dalton's law of partial pressure. So if you have two different liquid in a same beaker, so the one number liquid have its own partial pressure and the two number liquid have its own partial pressure. So if you have to calculate the total pressure, then you have to add the partial pressure of one number liquid and the partial pressure of two number liquid, and it's known as Dalton's law of partial pressure. Okay, here we get that Dalton's law of partial pressure. P total equal P1 plus P2. Okay, and we know that P1 equal x1 P1 naught and P2 equal P2 naught x2. I just put there. Okay, so one thing important that we learned that about mole fraction, that x1 plus x2 always going to be 1. We learned this thing in our previous videos. If you forgot, then go and check those videos again. Okay, and practice more and more, then it will be helpful for you. Okay, so in case of x1, we should put x1 equal 1 minus x2, right? So they just put the value here. In case of x1, 1 minus x2, and it's a simple mathematics. If you are going to calculate this, then you get this one. If you have any trouble, then I just try to write this for you, that here equal, sorry, here equal P1 naught minus x2 P1 naught plus x2 P2 naught. Okay, so it's like P1 naught, and if we are going to uh, uh, take that x2 outside, then we get P2 naught minus P1 naught, and this is that formula. Okay, so in this case we should calculate it. And what I want to say that you just try a different formula where you are going to put the value of x2 instead of x1. Like in case of x2, you should put 1 minus x1 P2 naught, and here it's the same x1 P1 naught, and just calculate this and try to find the answer. Okay, and then let me know. If you don't, then let me know, I will solve it for you. Just try for once. Okay, then here this from this we get that the total vapor pressure over the solution, I mean total vapor pressure means P total. Okay, so the total vapor pressure means that P total. The total vapor pressure by the solution can be related to the mole fraction of any one component. So what they said that the total vapor pressure can be related to any one component mole fraction. That means P total can be related to x1 as well as P total can be related to x2. Here in that example we see that P total is related to x2. Okay, P total is related to XO. So in this line they told that total vapor pressure of either solution can be related to the mole fraction of any one component. Okay, now you get that. After that, in 2 we see that total vapor pressure of either solution varies linearly with the mole fraction of component 2. So why they varies linearly? It's a question, right? So we know that it's in the form of, in that equation is in the form of y equal, this p1 naught is c plus this is mx. Okay, so y equal mx plus c, this a graph for linear. So if we are going to take p total versus x2, I mean the total pressure versus mole fraction, then we get a linearly curve. Okay, here we see that this curve one. Okay, this one. So in the third number they told that depending on the vapor pressure of the pure component, depending on the vapor pressure of the pure component 1 and 2, total vapor pressure of either solution decrease or increase with increase the mole fraction of component. It's depend on the pressure. Okay, so here we are going to learn this graph. So here the mole fraction of one number liquid is 1 and the mole fraction of two number liquid is 0. That means here only one number liquid is present, so it have the vapor pressure which is the purest for only for 1, so p1 not. Okay, and here only two number liquid is present and one number is not, so here the vapor pressure is purest of two number liquid and it's p2 naught. Okay, and why the value of p1 naught is less than p2 naught? Because the remember that the two number liquid is more volatile, so its vapor pressure is more compared to one number liquid. Okay, so if you are going to put we know that the graph will be linear, so it's like that and that, and the total is like p1 plus p2. Okay, it's not that tough, just remember that graph. And now we are going to learn about a new thing, and is that the composition of evaporation equilibrium with the solution is determined by the partial pressure of the components. If y1 and y2 are the mole fraction, if y1 and y2 are the mole fraction of the component 1 and 2 in the vapor phase. So what do you mean by y1 and y2? Remember that here we have two different liquid, okay, 1 and 2. So in that liquid form, if they have the mole fraction, then it's known as x1 and x2. But we know that after some time they will become vapor. Okay, they will become vapor, and in case of vapor they have some mole fraction, and in case of vapor it's known as y1 and y2. Remember that in case of liquids, mole fraction are x1 and x2, and in case of vapor, mole fraction are y1 and y2. Don't be confused about that. Okay, so in case of vapor phase mole fraction, we have a new formula, and remember that p1 equal y1 p total and p2 equal y2 p total. And in general we should like write like pi equal yi p total. That means I should be like 1 2 3 4 anything. Okay, so remember that. So now it's time for example 2.5. It seems like tough, but it's really very easy. Just try. Okay, so here the question is that vapor pressure of chloroform and dichloromethane at 298 Kelvin. Remember that the temperature is constant. It's 298 Kelvin, and the vapor pressure of chloroform, only chloroform, that means the purest one, is the 200 mmHg, and for only dichloromethane it's 415 mmHg. That means we came to know from here that the vapor pressure of dichloromethane is more. That means dichloromethane is more volatile compared to chloroform. So we have to calculate the vapor pressure of the solution prepared by mixing that much and that much amount of chloroform and dichloromethane. So question is really very easy, just try to understand it. Okay, so here what happened actually, that we know the value of P1 naught and P2 naught, I mean that purest form value. Okay, so we have to calculate the vapor pressure of solution, that means the total vapor pressure. Okay, total vapor pressure of solution, and they say that they are going to mix 25.5 gram of chloroform and 40 gram of CH2Cl2. So if we have to calculate P total, we must need, since we have the value of P1 naught and P2 naught, P1 naught and P2 naught, so we need the value of x1 and x2. So if we have to calculate the value of x1 or x2, so we know the formula that x1 equal N1 number of mole of 1 divided by total number of mole. We know these things from our last videos. If you forget, please go and check or study from your book. Okay, so if we have to calculate the value of x1, we need the value of mole, and we know that how can we calculate that mole? But it's by given mass and molar mass, and here the mass, given masses are there. We just have to calculate the molar mass. From this we get the value of n1 and n2, and from n1 and n2 we should calculate x1 and x2, and from x1 and x2 and p1 naught and p2 we can calculate the p total. So see that it's really very easy. Okay, so here okay, so now here this is the calculate that molar mass and that molar mass, and then we know the how to, you have to calculate the mole. It's given mass by molar mass, so we get the mole. Okay, so from that mole we should calculate the value of x1 and x2, and here after calculating these values they just put the values here and we get the total pressure. Okay, so and the second question is that mole fraction of each component in vapor phase. Vapor phase means we have to calculate the value of y1 and y2. So for y1 and y2 we know that formula p1 equal y1 p total and p2 equal y2 p total. So we already calculate the value of p total, right? So we have, since we have to calculate the y1, so we need that p1 by p total, so we need that p1 and we need that p2. Okay, so for p1 and p2 what we have to done, we know that p1 equal p1 naught x1. So we have the value of p1, we have value of x1, we just put it and we get the value of p1, and after getting the value of p1 and p2 we just put the value of p1 divided by p total and p2 divided by p total, and we get the value of y1 and y2. And now here it's a really very important note, and is that we know from that value of chloroform and of dichloromethane and chloroform, we get that we came to know that the purest value of chloroform is 200 and for dichloromethane is 415. So from that we came to know that the vapor pressure of dichloromethane is more. So since the vapor pressure of dichloromethane is more, that means the mole fraction of vapor value of dichloromethane is obviously more. Okay, so that's why we get the value of dichloromethane more, and it's 0.82, and for chloroform it's less, it's 0.18. Okay, so here we get that at equilibrium vapor phase will be always is in the component which is more volatile. That means which is more volatile, that liquid have more vapor phase, more vapor pressure, mole fraction value. Okay, so that's it. And after that, Raoult law as a special case of Henry law. We know that Henry law is equal P equal KH X, and Raoult law is P1 equal X1 PI naught. So here this KH is replaced by P1 naught, and in this case we get that Raoult's law in case of Henry law. Okay, you have to just write these two sentences like this two, that it can be seen that the partial pressure of the volatile component or gas is proportional to its small fraction in solution. So only the proportionality constant Kh and Pi naught, P1 naught is different. Thus Raoult's law becomes a special case of Henry law in which Kh become equal to P1 naught. That's it only. Okay. So now we are going to learn about vapor phase, vapor pressure of solution of solid in liquid. So in our next class I will going to teach about these things. So hope you study well, and if you have any query then let me know. Okay, take care a lot and study well.